Hi friends, I'm already back with another video. Seems like I just finished the last one a few hours ago, but if you watched the last one, or at least the introduction to it, you might have seen that it was about building a simple low-pass filter for low-frequency receiving. And in testing the filter, I ran into a little situation with impedance matching or lack thereof with the test results that reminded me maybe it's a good time to do a video on making sure that you have a filter terminated with the proper impedance when you're testing it. So I'll combine a couple of things in this video. We'll talk about testing the filter, and we'll also talk about testing this preamp, which I also built for low frequency receiving. So these are going to be used together, so we might as well talk about testing them together. So I'll go and get the test equipment ready here, and we'll get into this. Before we get into actually checking the filter on test equipment, I wanted to show you the theoretical computer model response of this filter. So here we have response of the filter plotted from 10 kilohertz to 10 megahertz here, and it's pretty flat. If you can see, follow my mouse pointer there in the vertical red line. It's pretty flat here up to certainly up to 300 kilohertz. At 300 it's says it's minus 0.15 dB. At 400 it's minus 0.49 dB. It's rolling off slowly above 400. At 500 it's minus 1.32 dB, so rolling off slowly. By the time we get to 600 it's minus 22 dB, so it's rolling off quickly then. And 700 is, if I can get right on 700, is minus 47 dB, and it just keeps going down from there. So this is the response we're looking for. Pretty flat up till about 400 kilohertz, then slowly rolling off a dB and a half between there and 500, and then dropping very quickly once we get slightly above 500. See, it really starts to drop somewhere around 530 or so here. So let's see if the results we get on test equipment agree with this. Hopefully they do. Well, I'll go ahead and tell you that in the end we will find that they do agree pretty closely with this once we get the test setup correct. And you'll see what I'm talking about here as we go through the next sections of this video. So ordinarily for this kind of testing I would be using the HP spectrum analyzer with tracking generator, which is the big instrument there in the middle between the oscilloscope, which you can see powered up, and the function generator down below with the red digits there that you can see powered up. But that preferred instrument is down with technical problems right now, so we're just going to adapt and use a different method of testing the filter and preamp response and the preamp gain. So I'm using the function generator as a signal source and the oscilloscope as a signal detector, so I can see if there's any attenuation of the signal or not at different frequencies, and see how much gain we have from the preamp at different frequencies. It's a little slower way to do it, but it will work fine. So first I wanted to before we get into testing, just show you that the test equipment itself is flat across the frequency range. Right now I've got the generator set to 10 kilohertz. Any flickering is an artifact of the camera and the the flicker rate of the display on the instrument there. It's not actually flickering like that, it just looks like it in the video. So that's at 10 kilohertz, and I've got the scope adjusted so we're peak to peak about plus and minus 4 divisions on the scope there. So I'm just taking the generator up a little in frequency. That's 20 kilohertz, 30, 40, 50 kilohertz, 60, 70, 80, 90, 100 kilohertz. I'm just going in 10 kilohertz steps. So we're up to 100 kilohertz now, and the level hasn't changed at all. The frequency has changed, so the thing is kind of scrunched up, and I can just reset the scope here. But the amplitude, the level, hasn't changed. So I'll just keep going, and I'll just let me hit the right button here. We'll just keep going up in frequency. I'm just stepping up through fairly fast now. There's 400 kilohertz, 500, 600, 700, 800, 900, and that's 1 megahertz. And still, the level is exactly the same. So the test equipment looks flat across the frequency range. Now I am going to reconfigure and show you this one more time. Right now I have the scope configured for high impedance AC input. I'm going to just reconfigure the scope for 50 ohm input, and we'll see why that's important later. But I'll reconfigure for that and just run this test one more time, just so you can see it's still flat across the range. It's important to be able to trust the test equipment before we start checking things with it. Okay, here we are back again, and I've configured the scope for 50 ohm input. And I should have noted before that the two instruments are just connected together. The output of the signal generator is connected through a bullet connector here to the input to the scope. So they're just directly connected together. So we're back at 10 kilohertz, and with these settings we're at 5 volts. Plus or minus 5 volts peak to peak, or 10 volts, 10 divisions rather. I'll get this right eventually. 10 divisions peak to peak here, or 5 divisions both above and below center. So we'll start stepping up through the frequency range here again. 20 kilohertz, 30, 40, 50, 60, 70, 80, 90, 100. I just readjust the time base a little for you here. And then we'll go to we'll keep going up like we did before. So there's 200, 300, 400, 500, 600 kilohertz, 700, 800, 900, and 1 megahertz, and the level still hasn't changed. So okay, the test equipment looks good. So let's go and see if we can check out this filter next. I'll let you see there that it is at 1 megahertz now, and the amplitude is still the same. So let's go check out the filter. Okay, so I've changed things a little bit. Now I've got the output of the signal generator here. Output of the signal generator is going into the filter. Output of the filter is coming into the oscilloscope. And we're at starting at 10 kilohertz, and it's adjusted for again 10 divisions peak to peak. So let's start going up in frequency. This should be what we're hoping to see here, is that it's pretty flat up to up to about 470 kilohertz or so, and then starting to slowly roll off and rolling off much faster once we get above 500 kilohertz. So there's 20, 30, 40, 50, 60, 70, 80, 90, 100. So it's dropping a little bit. Not a lot, because this is a pretty sensitive detector, but it is dropping. So we'll keep going up here, and it's not too bad. We're at 310 kilohertz now. 380, 90, 400. Now around 400 something's going on, because it's actually showing more output. In fact, let me Let me back up a little bit here, get down back into here somewhere, and we'll just adjust the scope so we don't keep running out of range like that. So in fact, I'll just go a little more. All right, so that's at 360 kilohertz. Now, if I keep going up, something strange happens in that now I'm getting more output. That's at 460 kilohertz. And it shouldn't be doing that. 470. Now it's starting to go down. So okay, it looks like it does roll off, you know, somewhere in here. But wait a minute, what happened there? Because I was at 530 kilohertz right there, and then as I go a little further, it keeps getting bigger, and it was going the wrong way. Excuse me. So, all right, let's get back to 530 kilohertz. There we go. Now, as I keep going up, 570, 580, there's a big peak right there. And how can it be that we're getting more power out of the filter than we're putting in? That can't be. It's a passive device, right? So something's not right. So it's not flat. It's just not looking flat at all. It's 580 kilohertz, and it's just way up there. Now above that, it does roll off. It rolls right off into the weeds here at 700 kilohertz. Is practically nothing left we can measure. So the point here is that you need to terminate a filter in the impedance it was designed for. This was designed to be a 50 ohm filter, for a 50 ohm coax circuit, 50 ohm receiver input. Although it's debatable if receivers are all that close to 50 ohms, but something in that ballpark. And this is a very high impedance scope input. So let's reconfigure this. I'll shut off the camera to do this, but I'll reconfigure the scope for 50 ohm input, and we'll just repeat this test again. Okay, so we're back. Scope is configured for 50 ohm input now. We're back at 10 kilohertz. We're adjusted for the same setting we had before originally. So let's just see if anything different happens. 20 kilohertz, 30, 40. That's 100. Just readjust this display a little bit. So we'll keep going up. There's 200, 300, 400. Now it is dropping some. It's dropping very slowly as we go above 400, so it's just starting to roll off just a little. 470 right there. But we didn't see that little peak, in the low 400s this time. 480, 490, 500, 510, 520, 530, 540. Now it's starting to roll off. Let's see if we get that peak at 580, 550. 560, 570, 580. No, we don't. 90 and 600, and it just right off. So now it's rolling off the way it should. So just the caveat to always make sure you terminate a filter in the impedance it was designed for, or something close to it, when you're going to be testing its response. Otherwise, you may see something that you don't understand or that doesn't look right in the filter response. Alright, so let me reconfigure the test equipment. We'll have a quick look at this preamp, and later we'll put the two together, but we'll look at the preamp and make sure it's working first. Okay, back again. So I have the signal generator output connected directly through to the scope input again. Scope configured for 50 ohms, and I've set a reasonably low level here because we're expecting to see a lot of gain with this preamp connected. So let me see. There's no way I can do that while holding the camera, so I'll just have to stop again and connect that preamp and then come back again. I need a better way for managing the camera, and I just don't have one. I have to hold it in my hands to do this, and it's very difficult to work with cables when you have a camera in your hands. So give me just a second here, and We'll reroute this RF so it's going through the preamp. Okay, we're back. Now we have the output of the signal generator here coming into the preamp input, the preamp output going into the scope. And I haven't changed any settings on the scope, and you see now that we're way off scale here. We've got a lot more signal than we had before. So in order to bring that back down, I'll have to do this. So to get back to where I was, I have to come down to 20 millivolts per division instead of 200 millivolts per division, and even then I've got a little bit more RF, not quite vertically centered, but I've got a little bit more RF than I had before there. So this preamp is supposed to have 20 dB power gain, which would be a voltage ratio of about 10 to 1, 10. So we're seeing a little more than that. So it's, it's 20 dB, maybe a little more than 20 dB, 20 and a half or 21 dB or something. So that's fine. I've got this at 300 kilohertz right now, which is kind of in the middle of the range I intend to use this for. Let me just dim this scope display a little there. So this preamp is supposed to be good from 100 kilohertz to 30 megahertz. I'm not going to check it over that whole range. I have checked identical builds like this before, and they are fairly flat within a dB or two across that range, which is not bad for a preamp. So let me just... Alright, we'll just leave that where it is. We're at 300 kilohertz. Let's go down and find where the lower limit is, where it starts to drop off. So we're going down... That's 200. That's 100. It hasn't dropped much there. Maybe just a tiny bit, but not significantly. 90, 80, 70, 60, 50, 40, 30. So, in reality, looks like this preamp does pretty well. We're all the way down to 10 kilohertz, and it's still got gain. It's dropped off some, but it's still got gain. So let's come up in frequency here. So now we're going back up. It had rolled off some as we got below 100 kilohertz there. So there's back to 300 kilohertz. Let me just get us a better display here. And just rapidly going up in 10 kilohertz steps. Pretty flat. Pretty flat. I'm going to stop at 1 megahertz because I'm not going to use this above that anyway. So 900 kilohertz and 1 megahertz. Okay, so yeah, pretty flat above 100 kilohertz up to 1 megahertz, and really doesn't lose all that much even going down to 10 kilohertz or so. It still certainly has gain down there. So that's interesting. Alright, so the next thing is to connect the output of the signal generator into the filter, the output of the filter into the input of the preamp, and then the output of the preamp into the scope to see how the two behave together. What I do not know is how close to 50 ohms the input of the preamp is. If it's not fairly close to 50 ohms, it may mess up the filter response again. So let's go and try and have a look at that, shall we? Back again. Now we have the signal generator output going into the filter output going into the preamp, and the preamp output going into the scope. Everything is still set for 50 ohms. We're at 300 kilohertz. So let's go up from here and see if we have any anomalies in this filter response that we can see. So there's 310, 20, 30, 40, 50, 60, 70, 80, 90, 400. Now remember, we started getting a little weird above this where it started increasing when we had high impedance. So there's 430, 440, 450, 460, 470. It's ever so slowly dropping off. 480, 490, 500, 510, 20, 30, 40. Now it's starting to really drop. 50, 60, and I've kind of run out of range on the scope. Let's go and just change some settings here. The scope is already, well, no, maybe it's not it. Yeah, it's already at max. Well, no, it's not. There we go. So there we go. Let's readjust so we can see this a little better. So now we've got a bigger display on the scope here. And let me just come down a little lower in frequency again. So there's back down to, well, let's just knock this down just a little more. All right, so that'll do. So we're back down here. We'll get back to 300 kilohertz. There we go. All right, so there it is at 300 kilohertz. We'll start going up in frequency. So it's dropping a little. That's 400, but it's not a lot. That's 400, 440, 50, 60, 70, 80, 90. So, you know, in reality, that's probably a couple of dB. I haven't done the math, but, you know, a couple of dB drop at 490, 500 kilohertz. Not too bad. I can live with that. 5, 10, 20, 30, starting to drop, 40, 50, 60, 70, 80, 90, and just keeps on dropping. So, yeah, okay. Looks like the filter is happy with the input of the preamp, being close to 50 ohms, so everything has the response it should. Well, just while we've got the two connected together, we'll just go down in frequency here and see what we get toward the low end. So there's, let me stop at 100 kilohertz here. So there's 100. Let's just readjust this a little, and we'll go down a little lower. It's 100 kilohertz. So we'll go to 90, 80, 70, 60, 50, 40, 30, 20, 10. So yeah, it drops off, but yeah, it's not ideal, but I suspect this preamp still certainly has some gain, and probably is quite useful even all the way down at 10 kilohertz. So there you have it. I believe the filter and the preamp are doing what I wanted them to do, and I showed you the importance of testing with the correct impedance on a filter, because otherwise you can get some rather odd results in checking these things, and they don't look like you thought they were going to look. So that's it for this time. I'm going to get into some other projects here, and I'm sure I'll be back with another video in a couple of days or so. Thanks for watching, as always. Hope you liked it.